Hello, I'm Andre Miller. I work for the Schistosomiasis Resource Center here at Biomedical Research Institute, and I'm going to demonstrate egg isolation from Schistosoma mansoni, infected livers. These livers were perfused yesterday. We left them in perfusion fluid overnight, and we're going to isolate the eggs from these tissues. Critical to the isolation, everything has to be ice cold. We're going to need a bucket of ice with a glass, high-walled petri dish, beaker for excess perfusion saline. I need ice cold, 1.2% saline. We have our sieves, which in graduated order, 425 microns, 180 microns, 106 microns, and 45 microns. We have a special blender jar for tissue, which is small volume. And the star of the show is our trusty dusty deck sprayer. We're going to add saline to the deck sprayer, pressurize it. We start with 4 liters. Once we start this, we don't want to stop it. The risk is that the eggs will warm to room temperature and start hatching. So we're going to make sure everything is ice cold. So that's why we have the 1.2% saline. First thing we're going to do is blend the livers. I put the livers in this special small volume tissue blender jar. And a little bit of noise. Because of the fibrosis that you get from mansoni infection, you really do need to grind the livers quite well. We need to liquefy them. We'll be grinding twice. These are 6 weeks infected animals. So 7 weeks, we'd actually have to grind 3 times because of the tissue is so dense. There's no harm to the eggs with this. The blade is raised up, so it grinds the tissue quite well, but it's not sharp enough to actually damage the eggs. 4 liters of 1.2% saline has been put into this deck sprayer. I pumped this, so I can't pump it anymore. The goal is once we start, we don't want to stop. So pressurize it, full volume, ice cold. Now what we're gonna do is use the pressure from the saline to push this tissue through the sieves, and we'll be collecting the eggs in the smallest sieve at 45 microns. The eggs are bigger than 45 microns, so they won't pass through. You want to come in? So what I do is pour a little bit in and then push the tissue through. Because we're going to grind it again, we're not too worried about what's collected, because what we're going to do is transfer this tissue that is bigger than 425 microns back into the blender jar. We're also going to collect what does not go through the 180 micron sieve. Any smaller than the blades in the blender jar aren't going to actually affect the size of the tissue. You can see that the water-soluble proteins leach out, so the tissue go quite dark, clear, and there's not much tissue left in the top sieve. This will be discarded. Now we're going to push the tissue through the 180 sieve and through the 106 sieve And you can see how much volume is in the bottom sieve. You really want to be careful about adding too much liquid because you don't want to overflow. That's why I have a catch basin below it. But what you notice is that the eggs have clogged the sieve. So I'm using gentle tapping, and what I'm going to do is create an opening for the saline to push through. And if you can notice, I don't know how well the camera's going to pick up, but you can see a slight yellow tinge to the debris. Those are all eggs. Now I'm going to transfer this to my petri dish that I have stored on ice. I like to rinse the plate out just in case there's ice. You don't want water. And easily transfer the eggs to the petri dish. And quickly, because room temperature is our enemy, put that on ice. Now that we have the eggs isolated from the tissues, we have them in a glass high wall petri dish. What we're going to be doing is getting the eggs into suspension by moving them in the saline. What we're going to do is get them in suspension because the eggs are heavy and they're quite sticky. So we want to remove them from the top of the glass and then put them back on ice to let them start to settle down. And then we're going to swirl them. I have paper towels to just absorb the water from the ice. I wipe it off, and then on my bench top, I gently swirl. Obviously, you want enough liquid in to get adequate movement of the eggs. And as you gently swirl them, you'll start to see them congregate in the center. And it creates, because they're yellow, a bed of what we call an egg yolk. And as you can see, past the foam is the eggs. And what we're going to do is capture them with the pasture pipette. You can see it pulling them up. And I'm going to transfer them to 15 ml conical. I'm going to not worry about trying to capture all the eggs because the process takes a bit of time and you want to continually move the petri dish back to ice so that the solution doesn't come to room temperature. But what you do is you take your time, you swirl, you collect, you keep going until you get no more visible eggs in the center. And what we have here is almost pure eggs. There's a bit of tissue as well. You can actually swirl all the eggs out and then start again with fresh saline and swirl them again, which would actually purify the eggs even more. You lose some eggs in the process, but you can get them to a point where if I made RNA from eggs that I've swirled twice, sometimes 3 times, PCR and use mouse primers and get no mouse signal. Okay, that's it. What's typically left behind are the dead eggs. Eggs that are laid early, especially in the 5th week. There is sometime egg laying. No more eggs.
No more eggs.
And, you know, there's small tissue debris that's left behind. And what we've gotten is a lot of eggs.